Molality is another way of measuring the concentration of a solution. It's not used quite as often as molarity, and that's why instead of representing it with a big M, we use a little m. To measure molality, what you do is you take and you measure the mass of your solvent, which is usually water, and you need your mass in kilograms. Then you figure out how many moles of your solute you put in. So our definition for molality, which is little m, equals moles, and this is moles of your solute, over kilograms of your solvent. A little different from molarity. Now how do we calculate molality? Molality equals moles on top, kilograms on the bottom. What might we need to get there? If you're starting with grams of your solute, you'll need to change them to moles, and you do that by dividing by the molar mass of your solute. This number would go on the top. Sometimes instead of kilograms, you'll be given grams of your solvent. To turn grams into kilograms, you divide by 1,000, and that would go on the bottom. Now, how do you know which is which? Here's an easy way to tell. Your solvent, which goes on the bottom, is usually water, because water is what we dissolve things in. Okay, let's do some practice problems. On your worksheet, look at question number 2. It says, what is the molality of 117 grams of sodium chloride dissolved in 2 grams of water? And it gives you the molar mass of sodium chloride. Let's think about our definition. Molality equals moles of our solute, which in this case is NaCl, divided by kilograms of our solvent, which is water. Do we know either of those? We know that we have 117 grams of NaCl. To turn that into moles, we're going to divide it by its molar mass, which is 58.5. 117 divided by 58.5 equals 2. So we're going to put our 2 moles on the top. 2 kilograms of water, that's what we want. 2 divided by 2, 1. And for our unit, we put a little m for molal. Now, how can we figure out how to make a certain molality solution? We're going to use our proportions again. In this one, we use a 0.45 molal solution of MgCl3. How many grams, make sure you solve for moles first, of MgCl2 would you need to dissolve in 4 kilograms of water? Notice once again you have your molar mass. Let's start out by taking our molality and turning it into a proportion. What does 0.45 molal mean? It means we have 0.45 moles over 1 kilogram. Keeping our units the same, we're going to solve for moles on the top, and we know that we have 4 kilograms. To solve for x equals, we're going to take 0.45 times 4 divided by 1, which tells us we would need 1.8 moles. Now we don't want our answer in moles, we want it in grams. So to turn moles to grams, we multiply by the molar mass, which is 95.3. So what do we get? 1.8 times 95.3 equals, we would need 171.5 grams of MgCl2. We'd need to dissolve that in 4 kilograms of water, and we would get a 0.45 molal solution. Now, why did we need to learn about molality? Pretty much because molality is needed to do calculations involving colligative properties. And colligative properties are needed to learn about freezing point depression. And freezing point depression teaches us how to make a certain dessert that we won't talk about yet.